So in this video, let's discuss some basic types of matrices. The first type we have is row matrix. A lot of these names are rather self-explanatory. So a row matrix is just a matrix where all the elements are arranged in a single row. So if I have a matrix like this, which is a 1 by 3 matrix, 1 row, 3 columns, is nothing but a row matrix. Next we have a column matrix, right? And as some of you must have already guessed, it's a matrix where all the elements are arranged in a single column. So let's take the same elements again, 1, 2 and 3, this time arranged in a single column. So this is a 3 by 1 matrix, just in a single, so that's a column matrix, 3 rows and 1 column. Next we have a zero or a null matrix, zero or a null matrix, right? It's a matrix where all of its elements are zero. So a matrix like this, 0, 0, yeah, all elements are zero, so it's a null matrix. Or something like this, 0, 0, 0, 0. Yes, these are all, both of these are examples of null matrix. The first one has an order of 2 by 1, the second one has an order of 2 by 2. So these are null matrices. Next type of matrix is a rectangular matrix. So matrix which is arranged in the form of a rectangle. So for it to be a rectangle, the number of rows should be unequal, or rather should not be equal to the number of columns. So suppose if I have a matrix like this, 3, 4, 1, minus 4, 6 and 9. As you can see, we have 2 rows and 3 columns. So this here is a rectangular matrix because the number of rows is not equal to the number of columns. Moving on, the next type of matrix that we could discuss is a square matrix. And no points for guessing here, but it's a matrix which is arranged in the form of a square. So the number of rows will be equal to the number of columns. So 2, 5, 1, 2, 1, 4, 5. Suppose if you consider a matrix as this. This one has 2 rows and 2 columns. Number of rows equal to the number of columns. So that is an example of a square matrix. Now, within a square matrix, there is a special type of matrix called as a diagonal matrix. Right, so a diagonal matrix is a matrix. Let's consider an example, 3 by 3 matrix. So a diagonal matrix is a matrix where the non-diagonal elements are 0 and the leading diagonal elements are all non-zero. So suppose if I have something like this, 3, 0, 0, 0, 8, 0 and 0, 0, 7. So this is a 3 by 3 matrix, and if you notice, all of the leading diagonal elements, when I say leading diagonal, I mean to say this diagonal which starts from the top left corner to the top bottom right corner, right? So all of these elements in the leading diagonal are non-zero, whereas all the other elements in all the other non-diagonal elements are all 0. Right, now within the diagonal matrix as well, there is a special type of matrix which is rather important for our course, known as an identity matrix, an identity or a unit matrix, right? An identity or unit matrix, right? It's denoted with the capital alphabet I. Now, an identity matrix is a matrix such that its diagonal elements are all 1. Right, so it's a diagonal matrix where all the diagonal elements are 1, non-diagonal elements are obviously 0. So this is a 2 by 2 identity matrix, and similarly, if I had to have a 3 by 3 identity matrix, it would be 1, 0, 0, 0, 1, 0, 0, 0, 1. So this here is an example of a 3 by 3 identity matrix. Now, why is the identity matrix special? It's because an identity matrix is similar to the number 1 in arithmetic. Now, suppose if I have 4 into 1, I can say 4 into 1 is nothing but 4, right? So similarly, a matrix A into its corresponding identity matrix I will be equal to A once again, right? So that is why, so this is a very important matrix as such. We need to remember it by its name. So identity matrix or unit matrix, denoted by the alphabet I. This point will be expressed, will be elaborated on further on when we are studying multiplication of matrices.